Okay, good day to each and everyone, especially to Ma'am Christine Alagasi. Since that we are conducting an online class in today's class schedule, so we just recorded our discussion for us to have a learning material. So we are the group 2 and we're going to discuss the new topic for today, which is the linear programming. Are you ready? Let's proceed to our learning objective. Is that at the end of the discussion, student will be able to discuss the nature of linear programming, determine the solution of linear inequalities, and apply the optimal solution of a linear programming problem using the graphical method. Okay, but before we start our new topic, which is the linear programming, let me first introduce myself. I am Shamira Ganinay Tatoy from BS Ed Social Studies. So, yes, let's start. So, it is better that we should first know the nature of linear programming, who invented it, and why it is still existing nowadays in our new generation. So, linear programming was invented in the 1940s by George Dantzig. George Dantzig is an American mathematical scientist who made contributions to industrial engineering and operation research. So the reason why he invented linear programming is a result of a military research project on planning how to distribute men, weapons, and supplies efficiently to the fronts during World War II. So when we say efficiently, it is something achieving maximum productivity with a minimum wasted effort or expense. And that's what gave birth to linear programming. So the goal of linear programming is to optimize. When we say optimize, it is to maximize or minimize. So optimize, on the other hand, is making the best or most effective use of a resource. So when we say maximize, it is to increase, and minimize is to reduce.
Programming in linear programming means creating a plan that solves a problem. This is not a reference to computer programming. So basically, some of us is confused about the difference of linear and computer programming, and some of us too also thought that linear or computer programming is kaparehas lang, or they have the same meaning because of the word programming. But we must always remember that linear and computer programming is really different with each other, because linear programming is a mathematical technique for maximizing and minimizing a linear function of several variables such as output or cost. So basically, ginagamit siya sa mga business, and ang computer programming naman is the process of writing instruction that are executed by the computers. So basically, naa siya written instruction hardware, which is often code kanang basically example sa computer programming is kanang mga website, kanang mga Chrome, YouTube, Facebook. So basically, computer programming is the process of designing and writing computer programs. Many businesses, industries, and government agencies use linear programming successfully. So, many of the businesses, industries, and government really prefer to use the linear programming method because this can help them to achieve the best outcome to solve their problems. And also, these mathematical techniques can help them to determine the best way to use their available sources. Kung tayo na sila mga problem about how to process the cost or how to minimize the cost. Basically, mas prefer nila ang linear programming is because maka-help man gud siya to make decisions about most efficient use of limited resources, like kung saan pag minimize the cost sa money, sa time, sa materials and machinery, and how to really use it in a very effective and efficient way. Business use it to determine the best way to manage personnel and workload in a specific job. So basically, ang linear programming is wala ang siya help sa business to help them on how to distribute their limited resources, but it also help them on managing their personnel and workloads in the best way as possible. Example ani is that scheduling of flights, which ginahimo sa airline corporation, which they make use of linear programming to minimize the cost without overloading a pilot crew with too many hours. So basically, it helps them to manage their personnel well, which can help them to satisfy their customer in the future.
So supermarket chain also use linear programming to determine which warehouse should ship which product and where to store. Additionally, linear programming is a mathematical technique which promise or assist you to apply or use available resources and the best procedure. So it really gives you a systematic way which will help you in a decision making.
Hello, my name is Michelle Katubag and I am going to discuss the linear inequalities. Inequality represents a mathematical expression in which both sides are not equal. If the relationships makes the non-equal comparison between two expressions or two numbers, then it's known as inequality. The symbol greater than and less than express the strict inequalities, and the symbol less than or equal to and greater than or equal to denotes lack inequalities. A linear equality seems exact like a linear equation, but there is a change in the symbols that is relates to two expressions. A linear equations in two variables, x and y, can be written in two forms. The first one is ax plus by is equal to c, whereas a, b, and c are constants. And the second one is y is equal to mx plus b, whereas m is the slope and b is the y-intercept. Such an equation is called linear because it is graph and it is a line. In this case, the equal sign in the expressions is replaced by any of the inequality symbols, such as greater than symbols, less than symbols, greater than or equal symbols, less than or equal to symbols, or not equal to symbols, turns a linear equations to a linear inequalities equation. Next are the formula. Ax plus by less than c, ax plus by greater than c, ax plus by less than or equal to c, ax plus by greater than or equal to c.
So for now, let's proceed on how to graph linear inequalities.
Solve the linear inequality for y. This puts the inequality in slope-intercept form. So when we solve the linear inequality for y, the inequality ma-transform siya sa slope-intercept form. If the inequality has no y, then solve the inequality for x. So if wala do siya y, pwede na i-solve na nato siya for x kaya wala man siya y. So if we multiply or divide each side by a negative number, it reverses the direction of the inequality. So if ato ana i-multiply sa negative number ang kada side sa inequality, so ma-reverse siya. So it means mabaliktad siya.
So now let's proceed to step 2 of how to graph linear inequalities. So step 2 is graph the line. So with regard to graphing linear inequalities, step 2 will teach us how to graph a line that is described by the equation associated with the inequality. So if the equation is in slope-intercept form, which is y is equal to mx plus b, then the line has a slope m and y-intercept b. So, if the equation is in the form of x is equal to a, then the line is a vertical line through a and 0. Okay, so an inequality can be presented graphically as a region on one side of a line. Now, inequalities that use less than, equal to, or greater than, equal to symbols are plotted with a solid line. So why? This is to show that the line is included in the region. On the other hand, if the inequalities that uses less than or greater than symbols, then it is plotted with a dash line. So why we have to use dash line? So this is to show that the line is not included in the region. So in graphing the line in your equation, you have to remember, or you have to make sure that the equation is in the slope-intercept form, particularly y is equal to mx plus b, where the first variable, where your m is your slope, and the second variable, which is b, is your y-intercept. On the other hand, in graphing the line of an inequality, you have to consider the two lines, or you have to think on when you should use the two lines, which is the solid line and the dash line. Now, the next step on how to graph linear inequality will be discussed to us by my co-reporter.
This is the third step of linear programming, shade in one side of the line. This is the example of y-axis and x-axis. Y increase as we move up kasi, di ba, yung vertical line, this is the vertical line. Yun yung y-axis, ang positive ng y-axis mula dun sa 0 pataas intersection x and y ay nag-increase siya ng 0, 1 to 5 pataas, kaya y increase as we move up and decrease as we move down. X-axis is horizontal line. Horizontal line is this horizontal line. As we move right, horizontal line. Ang y-axis is as we move right and decrease as we go to left. This is
Here we have our sample problem. Find the solution set of each of the following by graphical method. Objective: minimize 5x plus 10y, and subject to 2x plus y is lesser or equal to 10, and x plus 3y is greater or equal to 15. So that is our constraints. So the first step is we need to find the coordinates, the x and y. For us to find the coordinates, if you want to find the x, just substitute y to 0, and if you want to find the y, just substitute x to 0. So here from the problem, 2x plus y equals to 10, our x is equal to 5 and our y is equal to 10. So we have now our first coordinate, x5 and y10. So the second equation is 3x plus 3y equals 15. Our x is equal to 15 and our y is equals to 5. So after we have already found our coordinates, we need to graph the coordinates into the Cartesian plane. So as we all know, the x is siya yung nakahiga, saka yung y is yung nakatayo. So the first coordinates is x is 5, y is 10. So the first equation is yung red na arrow. Next is x plus 3y equals 15, or x is 15 and y is 5. Yung black naman arrow, yung second equation. After we have graphed the coordinates, we should determine the feasible region. So the feasible region, siya yung dito natin makikita paano mag-minimize or mag-maximize ng value. So we need first to test the feasible region. So assume that x and y are equal to 0. So the first equation, 0 is less than or equal to 10. So true. So if true, ang shade natin is paloob. So second equation, x plus 3y is greater than or less than 15. 0 is greater than or equal to 15. So false. So kung false is palabas ang ating shade. So kita nyo yung blue shaded area, that's the part where the two coordinates meet, yung same sila ng shade. So that's what we call feasible region. Diyan natin makikita kung saan sila nag-meet. So we have 3 vertices, as you can see, tatlo yan sila. First is the 0 and 10. Second is 0 and 5. And the next one is 3 and 4. So after that is we need to go back to our objective function and substitute the values that we have in our vertices. So and let's because our objective is to minimize the cost, so we need to find the lowest computed value. So here, so we can see the lowest computed value is the coordinates of 0 and 5 because it has only 50. So that's it.
And let's proceed to another problem that will aid us understand more.
So here's another problem. So this problem is to maximize the profit. So I hope you can see the problem. So the objective function is z equals 90x plus 180y. So we need to maximize this the profit, the sales. The constraints are 2x plus 5y is lesser or equal to 4, and 15x plus 45y is lesser than or equal to 15. So first we need to find the coordinates, the x and y, for these two constraints. So for the first equation, x, if you want to find the x, just like what I said earlier, just substitute y to 0, and if you wanted to find y, just substitute x to 0. So for the first equation, x is 20 and y is 8. So for the second equation, x is 21 and y is 7. So let us first determine the feasible region. Kumbaga, para malaman natin ang saan tayo mag-shade. So for us to determine the feasible region, just substitute x and y to 0. So the first equation, 0 is lesser than or equal to 40. So true, tama. So papasok ang ating shade. Second equation, 15x plus 45y, 0 is lesser than or equal to 2015. So tama naman siya, lesser than naman talaga ang 0. So ang ating shade is papasok. So let us now proceed to the plotting sa ating x and y. For the first equation, the x is 20 and the y is 8.
So, ito, for the first equation mo to, ito siya. So, for the second equation, x is 21, tabi lang sila, and the y is 7. So, as we can observe, ang shaded area kung saan sila nag-meet is dito. So, that's the feasible region. Diyan natin ngayon tingnan ang mga vertices para ma-maximize natin ang objective function. So, saan siya nag-meet? May tatlong vertices. So, the first vertex is 0 and 7. X is 0, 7 is y. Second is x is 20, 0 is y. And the last one is this, 15, x and 2 is y. So, kung gusto mo, if you wanted to have an accurate coordinates for this one, you can use the elimination method. Pero ito, accurate naman din ito. Sige. So, because meron naman tayong mga vertices, we can now substitute these numbers sa ating objective function, sa ating equation. So, let's just translate this x and y numbers in and solve the equation. So, for the first coordinates, x is 0 and y is 7. So, answer is 1 to 60. 2 is 90. 15 is x. And the y is 2. So, the answer is 1,710. Lastly, the x is 20 and 0 is y. So, 1/8. So, ang question is, i-maximize natin ang profit. So, dito. Sa question, how many tables and rocking chairs should he make to maximize his weekly sales? So, paano na natin malalaman? So, should look at the subjective function ng mga answer nito. So, 1,800 is the pinakamataas ni na sales niya. So, he needs 20 tables and 0 chair to maximize his weekly sales. So, he needs to focus more on making tables. So, the second question is, determine the maximum sales and profit he can make per week. So, let's say for example, ito ang the maximum sale niya. Kasi ito naman talaga, di ba? 1/8. So, minus 315. 315 is the cost sa kanya, paggawa ng tables and chairs. So, i-minus lang natin yan, and the answer is 1,485 is his total profit in a week. So, I hope you guys understand, and thank you.